Welcome back to the discussions and thank you for always joining us. We are presenting a question that was done in K.c.s.e 2004 paper 2 question number 19, a question on bearing and scale drawing. And the question we have reads, 4 electricity posts A, B, C, and D stand on the level ground such that B is 21 meters on a bearing of 60 degrees from A. So we are going to have AB, which is 21 meters. So the scale that we have been given to use is 1 centimeter to represent 3. So we are going to divide by 3 to get 7 centimeters. We are also told that the angle is 60 degrees. C is 15 meters to the south of B. Again, we have BC, which is 15 meters. You divide by 3. We are going to have 5 centimeters. That is between B and C. Again, we have been told that D is 12 meters on a bearing of 140 from A. That means, again, AD, we are going to have 12 meters. That is 12 out of 3, which is 4 centimeters on a bearing of 140 degrees. So we are going to begin by using our scale to draw the diagram to show the relative positions of the posts. So we begin with A, then locate B. So I'm going to begin by having a point A. We draw the compass at point A. So this is a point A, which is the starting point. Then we are going to measure 60 degrees to locate B. So 60 degrees is going to be at this point here. So we can draw a line straight from A to B. We have been told that the total distance from A to B is 7 centimeters. According to our scale, 7 centimeters is at this point here. So we again come and draw another compass at this point here. This is point B. As you can see, 7 centimeters. We move to the next point. We were further told that C is 15 meters to the south of B. 15 divided by 3, you get 5. So we are going to move down 5 centimeters. 5 centimeters is at this point here. And this is where we are going to have our point C. So once we are able to locate a point C, you draw another compass at point C. We now move again and locate another remaining point. D is 12 meters on a bearing of 140 from A. So we are going to measure 140 degrees and locate a point D, which is 12 meters. So if you take 12 divided by 3, you get 4 centimeters. So 140 degrees, we are going to measure from the north pole of A. 140 is at this point here. Then draw a line downwards. But remember, from A to C, we are going to draw exactly 4 centimeters. This is 4 centimeters. And from there, we have our compass at this point here. We're going to draw our compass at this point and call it a point D. Once we have point D, now we can join D and C for us to complete our diagram. That is exactly the diagram that we have. And once we are through with that, we are supposed to find the distance and the bearing of C from D as the first part of this question. That is A Roman 1. Then A Roman 2. A Roman 2, we are supposed to find the distance and the bearing of C from D. So we need distance DC. And for us to get the distance, we are going to measure DC in centimeters. And if you measure the distance DC, you realize it's going to be around 3.8 centimeters. So you take that distance, which is 3.8 centimeters. You convert it back to scale by multiplying by 3, and that one gives us 11.4 meters as the answer to that particular question. Once we have done that, we can now move to part B of the question. And part B of the question says that the height of the post at a point A is 8.4 meters. On a separate scale drawing, mark and determine the angle of depression of the foot of the post at C from the top of the post at a point A. So what we are going to do, we are going to take the post from a point A. We are going to draw a post which is going to be 8.4. You divide by 3, giving us 2.8 centimeters. So we are going to draw 2.8. So we are going to draw 2.8 at this point here. This is our point A, which is 2.8 centimeters. We come and draw AC, but first we are going to measure AC. AC is 6.2 centimeters, as you can see there. So we are going to draw 6.2 centimeters from this point. You realize we cannot be able to achieve that. Let me now try to bring it down a bit. So I'm going to draw 2.8 centimeters at this point here. This is our point A, 2.8 centimeters. Then come and draw 6.2 towards C. 6.2 is here. So this is where we are going to have point C. Now we can join the top of the post to C. That is exactly what we have. We need the angle C, but remember we need the angle of depression. The angle of depression that we are looking for is going to be the angle theta at this point. And for us to do that, this is 6.2 centimeters. We can either use trigonometry to find that particular angle theta, or we simply measure the angle at that point for us to get exactly what we are looking for. So if you use your protractor well and place your protractor at this point, you realize we are going to have that angle here. So it's very clear that the angle we are looking for there is 24 degrees. That angle is 24 degrees. Angle of depression will be equal to 24 degrees. Of course, we need plus or minus 1 degree. Or you can as well use trigonometry to get the angle theta by saying the tangent of an angle, since the opposite is 2.8 over 6.2, meaning to get theta we find the tan inverse of 2.8 over 6.2, and this one is going to give us approximately 24 degrees to the nearest whole number. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.